Hello there guys, and welcome back to another epic Inexorable video. In this video we're taking a look essentially at finding the equation of a perpendicular bisector, okay? So a few things, we need some prerequisite knowledge for this video straight out the bag. We need to make sure that we know how to deal with parallel and perpendicular lines, the midpoint of a line, and the equation of a line. We need those bits of information, we need that knowledge for this video. It's going to involve quite a lot of things. And this is essentially the last video that we're dealing with straight lines, straight line graphs, things like that, okay? So this is the perpendicular bisector of a line, okay? What is a perpendicular bisector? We can kind of break it down. Of course, perpendicular means 90-degree angles, right angles to each other. Bisector means something that intersects this line in the middle. It cuts it into two. It bisects it, okay? So a perpendicular bisector is a line which passes through the middle of, or bisects a line segment at a 90-degree angle. That's all it is. It's, you know, conceptually, it's not a big deal, you know? If you've got a line that goes like this, its bisector is going to go like this, roughly, right? That's the general gist of it. But we need to know how to deal with the equations of this, okay? We need to know how to actually put everything together and find the equation of a perpendicular bisector, which is actually not an easy feat. Second of all, as I've written, any line segment with a gradient m basically has its perpendicular bisector always having a gradient of -1/m. That's because it doesn't matter what the bisector is. If a line, it doesn't matter how long the line is or where it starts and stops, the equation of the perpendicular bisector is always perpendicular. It will always have the same gradient. So whether or not, for example, let me just make sense of what I'm saying. If you have a line segment that goes like this, or a line segment that is parallel but is longer, starts in a different place, maybe it's like this, you know, and we're on some arbitrary coordinate axis, okay, doesn't really matter. The gradients of both of these lines, perpendicular bisectors, are the same. So for instance, this one might look like this, and this one might look like this. If we assume they're both 90-degree angles, they have the same gradient. Basically, any line with a certain gradient m always has its perpendicular bisector with a gradient of -1/m. And that is for the reason, as we explained in the parallel and perpendicular lines videos, that is for the reason that they're always perpendicular. So without further ado, let's just get into a question, okay? So essentially, we want to find the equation of the perpendicular bisector of the line segment joining the points 3 - 3 and 13 - 7. This is this. Again, I hope I've drawn this big enough. We need a bit of space for this question, so I couldn't make it too big, but I hope this is readable. So I've already plotted it. It's potentially for this sort of question, it is a good idea to plot. So we've got 3 - 3 as one of our points and 13 - 7 as another one. Essentially, this does make up a line with an equation. It's just been cut off, like here and here. This line has still got some sort of equation, hasn't it? It's still got some sort of gradient, but I've just said, actually the part of what we're talking about is this part of that line. It's just 3 - 3 to 13 - 7. That's what we're talking about. What we want to do is not only find the midpoint, because we need to of course find the midpoint, which is going to be about here, which we will calculate in a second. We also need to find the gradient of the perpendicular bisector, which is going to sort of come up like this, isn't it? And we also need to put that into the equation of a line. We need to be able to completely turn it into the full equation of a line. So there's a lot of things going on. Let's just have a go at it. Let's do it step by step. Let's just do it. So the first thing that you should do is figure out what is the midpoint of this line. The previous video that I made covers how to do that, so this is going to be assumed knowledge. The way that we find the midpoint is we add the x coordinates and y coordinates together and we half them individually. So for instance, we're going to do 3 plus 13. So I'm going to label this point M for midpoint. and I'm going to say it's 3 plus 13, because those are the sum of the x coordinates, halved. That averages the x coordinates. We want to find the average x coordinate. That will be the middle x coordinate. And then we're going to go for the average of the y's. It's going to be minus 3 plus minus 7. Okay, so minus 3 plus minus 7. Again, this is the sum of the y's. Minus 3 plus minus 7. Again, halved because we're finding an average. That implies that the midpoint m, capital M by the way, this is going to be capital M, don't confuse it with lowercase m, which will represent gradient. Capital M for midpoint, well this is 3 plus 13, that's 16. Half of 16 is obviously 8, so it's going to be 8, and then minus 3 plus minus 7, that's going to be minus 10, isn't it? Because again, these two plus and minus, they make a minus. So it's minus 3 minus 7, that's minus 10. Half that, you get minus 5. So the midpoint has coordinate 8 minus 5. So we're going to label this point here 8 minus 5, okay? That is the middle of the line segment that joins this coordinate and this coordinate together. It's the middle. Now, all we need to know is the gradient of the perpendicular bisector. We know a point that it goes through. Remember, to formulate the full equation of a line, all you need is the gradient of that line and one point that it goes through. We've already got a point it goes through. The perpendicular bisector it bisects the line. By definition, it has to cross 8 minus 5, hasn't it? It has to. So that's one of our points. Now we just need the gradient. Now, to do that, we need to find the gradient of the original line, and then we can do our negative reciprocal business. So we need to find the gradient of the original line. So how do we find the gradient? We use the formula lowercase m, okay? And I'm going to call this m sub 1. So m1, like a little 1 down there, because this is going to represent the first line. The second line, I'm going to end up calling that m sub 2, or m and then a little 2. Just labeling. This is not a mathematical operation. This is just saying the first one. And then we'll call the second one, if that makes any sense. So that's going to be equal to, remember the formula guys, I haven't written it down, but remember the formula. The formula is the change in y divided by the change in x. So it's going to be y2 minus y1 over x2 minus x1. So I will write that. We'll write it up here. The gradient of a straight line is y2 minus y1 divided by x2 minus x1, okay? That might be just something to make a note of, remember that. So, how do we do it? Well, here's our x1, y1, x2, y2. We just substitute in. So y2 is minus 7. Again, I do have 2 videos on this. And so we have minus 7 minus y1, which is minus 3. So minus 3 divided by the change in x. So x2 is 13. Again, all we're doing is just using, all we're doing is just using this formula up here. And then we have 13 minus x1, which is 3. Just like that. And then we have minus 7, minus minus turns into a plus. So this is minus 7 plus 3, if that's clear. And that ends up being minus 4. And that's being divided by 13 minus 3, which is 10. And that simplifies, minus 4/10 simplifies to minus 2/5, doesn't it? Just dividing the top and the bottom by 2. The gradient of the original line, this one, is therefore negative 2/5. And guys, look at it. That looks right. That looks absolutely right to me. You know, negative 2/5. This would be negative, this would be like negative 1, negative 2/5, bit less. Obviously, I haven't drawn it perfectly accurate, but yeah, that seems about right to me. Perfect. If we got like a positive number, we would know it's wrong, but it's not. It looks about right, so we're going to go with it. That must be right. Always check your working as you go through. I'm happy that that's correct. So now, how do we find M2? Well, we know because the lines are perpendicular, again, by definition, perpendicular bisector, we know that M2, which is going to be the, essentially, where's the ruler? Essentially, M2 is going to be this new line, the perpendicular bisector, like that. We want to find the gradient of this bad boy, this new guy. Well, how do we do it? They're perpendicular. They make 90-degree angles. We use the formula m1 equals negative 1 over m2, or they multiply together to make negative 1, or however you want to talk about it. We're going to say it's going to be 1 over m1, which is this. So 1 over minus 2/5. This is the gradient of the new line. Now let's simplify some things. There's a negative here, there's a negative here. They cancel out, they make a positive. That's going to be equal to 1 over 2/5, like that. And again, guys, I spoke about in a previous video, if you want to simplify this, all you do is you take the very bottom number, so 5, you just bring it up to the top and just multiply by whatever's at the top. So you do 5 times 1, 5. And then you end up getting 5 over 2. If you're not sure how to do this, if you're worried about doing this, you can do it on a calculator. It will simplify it for you. Or you can use keep, flip, change, or you can multiply the top and the bottom of the fraction by 5. You will get 5 over 2. So it's 5 over 2. It's the negative reciprocal. You see this relationship? One of them's the negative of the other. They're both being times by 1 in comparison to each other, and they're still reciprocals. 5 over 2, 2 over 5, like that. So the gradient of this new one is going to be 5 over 2. Again, guys, looks right. It's positive. It's quite steep, so it's probably steeper than 1, which would be a 45-degree angle like this. It's a bit steeper than that. It's 5 over 2. It's got a gradient of about 2.5. 5 over 2 is 2.5. Perfect. But we're not at the end yet, guys. We need the actual equation, don't we? How do we find the equation? We use another formula. This is where everything's coming together, guys. This is where you need to be really making sure you're happy with all of the stuff in straight lines. Now we need to use another formula. This formula, I'm going to do it up here. I hope that's not confusing. I'm going to do it up here. This is going to be y minus y1 equals m, that's a lowercase m, that's gradient, times x minus x1. Again, I've got a video on this. It's called Finding the Full Equation of a Straight Line or something like that. We talk about how to use this formula. If you essentially have the gradient and one pair of coordinates, you can find the full equation of the line in the form y equals mx plus c, or in the standard form as well, but we're going to use y equals mx plus c, not ax plus by plus c equals 0. We're going to use y equals mx plus c. So guys, we're going to just substitute in. We know one point that this line goes through. We found it. It's 8 minus 5. So let's just substitute in. Clearly, 8 is x1 and minus 5 is y1. So y minus 5, because that's y1. y1 is minus 5, so it's y minus 5, is equal to m, which is 5 over 2. We need to use that one, times x minus, and then x1 is 8, like that. And then, guys, we just need to simplify. So this is going to be y plus 5, because there's two negatives there, is equal to 5 over 2 times x, and then 5 over 2 times minus 8 is going to be 5, that's 40 over 2, so it's going to be minus 20. Is that right? Yep, that's right. So, yeah, so 2.5 times 8 is 20, negative. And then, guys, we just need to take 5 away from both sides. We get 5 over 2x, and then minus 20, we're going to take 5 away from both sides. Minus 20 minus 5 is minus 25, just like this. This is the answer. So essentially, this is the full equation of not the normal line, but this line, the perpendicular bisector. It's this equation here. Again, guys, it looks right. It's got a gradient that is indeed perpendicular. We know for definite that this is correct. Look at it, the y-intercept, minus 25. Yeah, looks about right, because if this guy came all the way down here, it would intersect about there. Yeah, as long as it's negative, you're on the right track. Again, if we got that this was like a plus 25 or 0 or something, again, we know it's wrong, because look at the diagram. If it's in any way drawn accurately, our y-intercept must be negative. So you can check your answer by going, yep, that looks like it's about minus 25. Again, if we were being told that the y-intercept was like up here, we'd say, well, that must be wrong. But it's not wrong, we're about here. So that is how you do it. There is so much going on, isn't there? So you have to know how to use quite a lot of formulas. We've dotted them around. We've got this one, we've got this one, we've got the gradient one. Oh no, that's the one up there. The midpoint one. There's, I think, 3 different formulas for this, guys. And also just a lot of mathematical intuition. So guys, without further ado, that is the end of the video. Really, really practice these things, guys. Really practice them. These are the hardest things in straight lines, probably. So, and you know, they can get harder even. So, you know, watch out, practice, and thank you guys for watching. And I will see you in the next video. Cheers.